In this video, we will add some more video controls including vertical syncing, anti-aliasing, shadow quality, and texture quality to our settings menu. Now that we've finished brightness and render distance, it is time for us to get into the core of graphical settings within Unity. Inside project settings, we can modify many graphical settings with most, if not all, of them affecting the performance of the game. We will be focusing on creating presets that will control our vertical sync, anti-aliasing, shadows, and texture quality. We will also be controlling these individually. Let's just jump right into it. Before we start, we found some more bugs. This time, it's with finding resolutions for certain monitors. When we tested the settings menu on an older monitor, we noticed that although the editor sees about 13 resolutions, all of which are 60Hz, the resultant build displayed 10 extra resolutions. In addition, most of these 60Hz resolutions became 59Hz. As a result, our current code would only get the 60Hz resolutions and nothing else. According to Microsoft, certain monitors report a TV compatibility timing of 59.94 Hz. Therefore, Windows 7 and newer versions of Windows expose two frequencies, 59Hz and 60Hz, for every resolution that is supported at that timing. Both 59Hz and 60Hz are translated to 59.94 Hz before these values are sent to the driver. Therefore, the display is identical at 59Hz and 60Hz. So, from that, we can safely assume that 59Hz and 60Hz are the same and will create a special condition for this scenario. We'll start by making countRes a method level variable rather than a class level variable. We'll also make store resolution a list rather than an array. This is mainly because we initially made store resolution take on the entire length of our list of resolutions. This resulted in some unused entries inside store resolution, which is inefficient. Change .length to .count for the for loop inside load settings. Let's create two private integer variables named resWidthMax and resHeightMax, both of which are assigned a value of 600. Inside the for loop, we'll initially check if the resolution height and width is higher than these values to filter out absurdly low resolutions. Now, if the current screen refresh rate is between 59 and 60, and the resolution being added has a refresh rate between 59 and 60, then we will check the current value of countRes. CountRes tracks how many resolutions have been set inside store resolutions. If we have yet to put anything in store resolutions, we will just store the first viable resolution inside store resolutions. Any subsequent viable resolutions will check to see if the height and width are duplicate entries by checking the last stored resolution in store resolution. If it's not a duplicate, then we will store it. For all the other refresh rates, and assuming all other refresh rates do not have this kind of problem, we will simply just check the screen's refresh rate to the resolution's refresh rate and add it if it matches. With that, the 59Hz and 60Hz problem has been resolved. We also made several other changes to help make the code and project a bit cleaner and more understandable. The changes are optional, but the next few seconds will cover all of our changes. We will begin with vertical syncing. Vertical syncing is a video display option that is widely used between every game. It's mainly used to prevent the visual artifact known as screen tearing. In Unity, the frame updates are not necessarily synchronized with the refresh rate of the display device. In this case, Unity will often issue new frames to the display device, but the display device has yet to finish rendering the previous frame, causing the screen tearing. Luckily, Unity supports V-syncing inside the project settings. Under the dropdown, we can synchronize the frame switches with the device's vertical blank or with every other vertical blank. A vertical blank is the period at which the display type is not updating. As such, we can synchronize the Unity frame switches with the vertical blank in order to prevent Unity from switching frames when the display device is not finished updating. We will be focusing on using don't sync and every V blank. Open our settings prefab. Start by going under Content and making a new game object. Under this game object, we will create a toggle. Under the toggle, remove the label and adjust the toggle background to be however big you want. Make sure that the toggle and background are anchored to the center. Add a label to the left and name it as VSync. Open the settings script. We will make a new header called toggle. Under this, we'll create our vsync toggle. Inside the button events function, we will add the onValueChanged event to the toggle, delegating a function call to vertical sync with the current toggle state as the parameter. Under vertical sync, we will check this toggle state. If they change it to be true, then we will assign vsync count with a drop-down position labeled with every v blank or position 1. If not, then we will assign vsync count with a drop-down position labeled no vsync or position 0. We will then set the state of our toggle without calling the button event for loading purposes and set this boolean to our scriptable object. Go through SO settings, settings file, and load settings file and add in the new vsync boolean variable. In our load settings function, we will set the checkbox depending on what boolean we got from the scriptable object. Go to the default scriptable object and set the boolean to whatever you wish. We set it to be true. Once finished, attach the toggle to the script, delete the settings file, and test. You should see the vsync toggle being set accordingly. Make sure to mouse over the project settings inspector. The values are updated upon mousing over. Also, make sure to save the settings using the save button to keep the changes between plays. Now let's build and test this project. Please note that vsync caps the FPS outside of the editor. We will use an FPS display script to see the effect once we test the game. You'll notice that vsync caps the FPS to the screen's refresh rate when toggle is on. If it's not on, then the FPS will be uncapped and becomes dependent on the strength of the PC. Try this on different display types. It should all work the same. Now it's time for anti-aliasing. Most games only have a small number of anti-alias options, and there are quite a few of them available in Unity. We can use multi-sampling anti-alias inside our project settings, or we can use fast approximate anti-alias, sub-pixel morphological anti-alias, or temporal anti-alias located inside our post-process layer under our camera. We will be focusing on MSAA and FXAA since these two are the more common anti-alias options used. When you look at your scene without anti-aliasing, you may notice a lot of jagged edges on your models. This is because each pixel on our screen can only take on one color, and with no anti-aliasing, each pixel will either take on the color completely or it will not. This causes this jagged, stair-like pattern. It's up to you on which anti-alias technique you want to use. Every technique has their own pros and cons. As an example, MSAA is a lot more taxing on the system compared to FXAA. However, MSAA looks arguably a lot better than FXAA since FXAA produces a lot more blurry edges for their models and textures, while MSAA produces sharper looking images. Open our prefab, duplicate any of our dropdowns and change the labels and text to refer to anti-aliasing. Under our dropdown, change the options to be None, FXAA, MSAA 2 times, MSAA 4 times, and MSAA 8 times. Inside the settings script, add a new dropdown under the dropdown header. We'll also add a new private variable that will take on the post-process layer found on our camera. Assign this variable inside the initializeBeforeLoad function by using getComponent on our camera. Inside the button events function, we'll add an onValueChanged event and delegate a call to a new function called Anti-Alias with the dropdown value being passed in. Inside Anti-Alias, we'll start by controlling MSAA. If any of the MSAA options were chosen, we will choose the correct dropdown in the project settings. What's odd is that this dropdown is selected by their anti-alias sampling value rather than their indexes inside the dropdown. As such, we'll use 2, 4, and 8 to represent the 2 times, 4 times, and 8 times MSAA sampling. Now, if FXAA is chosen, we will choose the appropriate anti-alias mode in the post-processing layer, but otherwise, it will be set to None. We will then set the state of our dropdown value without calling the button event for loading purposes, and store the dropdown chosen inside our scriptable object. Again, go through SO settings, settings file, and load settings file, and add in the new anti-alias variable. Under load settings, we will call the anti-alias function using the integer set by the scriptable object. Go to the default scriptable object and set the default anti-alias option to whatever you wish. We chose 0 for None. Once finished, attach the anti-alias dropdown to the script, delete the settings file, and test. When you choose FXAA, the post-process layer should display the correct anti-alias option, and the project settings anti-alias should be set to None. When you change to MSAA, the project settings should choose the appropriate dropdown, and the post-process layer anti-alias should be set to None. Check to see how each anti-alias setting affects your game. Also, check the scriptable object to see if everything is recorded correctly. With that, anti-alias is complete. We'll now start with shadows. In the project settings, we are given a lot of control over our shadows. Each property has their own unique effect on shadows, so we highly recommend you read the documentation covering each of these options. For us, we will be controlling shadows with one single dropdown from very low to very high. Inside our settings prefab, duplicate one of the dropdowns and change it to account for shadows. Make the options as very high, high, medium, low, and very low. Inside our settings script, we will get this new dropdown and assign an onValueChanged event that calls our shadows function. Depending on the chosen dropdown index, we will call another function called changeShadows that will take in the shadow mask, shadow quality, shadow resolution, shadow projection, shadow distance, shadow near plane offset, and shadow cascade that we will set ourselves. changeShadows will then take these values and apply that to our quality settings. Each of these dropdown indexes should correspond with the quality level you established in the dropdown, so be sure they are in order. We will then set the state of our dropdown value without calling the button event for loading purposes, and store the dropdown chosen inside our scriptable object. Go through SO settings, settings file, and load settings file and add in the new shadow integer variable. Under load settings, we'll assign the dropdown value and call the shadow function with the index found on our scriptable object. Go to the default scriptable object and set the integer to be 2. Once finished, attach the shadow dropdown to the script, delete the settings file, and test. You should see the shadow properties changing depending on your dropdown. Test to see if it saves. Test to see if it reverts without saving. With that, we are done with shadows. With everything we have learned, texture quality should be very simple. Try doing it yourself. The final script will be given at the end if you want to see how we did it, but it's the same process as how we did everything before. Note that there are only 4 options we can choose from for texture quality. We will go as low as 1/4 of the resolution. In other words, there's only 3 options. Once completed, we will now work on presets. Before we do that, we'll establish some settings in the project settings for each level. Inside the project settings, modify the quality levels to match what we established. You may change these yourself. The custom level will be established later. Now just do the same initial setup for presets. Duplicate a dropdown and establish your options, preferably matching the level names themselves. We'll extend our content to encapsulate all of our settings. We'll also increase the scroll sensitivity to 40 and make the movement type as clamped, if not already done so. Inside the settings script, create a drop-down variable for presets and add an onValueChanged event that calls for a function called preset and sends it the chosen preset value. Change the quality level depending on what dropdown the user chose using qualitySettings.setQualityLevel. Access SO settings, settings file, and load settings file and add in your preset value. Attach the preset dropdown to the script and add it to the load function. Now, you may have noticed that we called a function called changeDropdowns. In order to reflect these quality changes to our dropdowns, we must call each of their corresponding functions while passing in values that match the settings found on each quality level. As an example, anti-aliasing is set to MSAA 8 times for our very high quality level preset, so we will pass in a value of 4 when calling for the anti-aliasing dropdown in order to match this quality level. But before we continue with that though, let's implement our custom preset. Let's add it to our options list and include it as an option under preset. Now, each setting function that is affected by the preset will need to be passed in a boolean. This is because we are utilizing these setting functions for 2 purposes, one for changing the dropdown and one for applying the quality setting. If they chose a preset, qualitySetting.setQualityLevel already applies the quality setting changes, so it would be redundant to double up on these changes. We only want the dropdown and scriptable object assignment portion of the function. Therefore, we'll only access the setting changes if they chose an individual setting change. We'll do this for VSync, anti-aliasing, shadows, and texture. We'll now finish up our change dropdown function with each of these function calls setting true, since these are presets. However, we'll send it as false for our custom preset and pass in the current dropdown values or toggle value to the functions instead. We also need to change the function calls in our button event and load function. We'll make them all pass in as false since these are not preset calls. In our load function, we'll have 2 scenarios. If the user chose a preset, then we will enter our preset function and set the quality and dropdowns to the preset values. If the user has a custom preset, then we'll apply each of the custom settings individually on load. Another thing we need to do is to automatically change the preset dropdown to become custom the moment they choose an individual setting. Just change the preset dropdown and assign the preset value into the scriptable object for VSync, anti-aliasing, shadows, and texture. Under our default scriptable object, set the number to be 2. By setting this default setting, all the settings affected by the preset function are now irrelevant. This includes the VSync, anti-aliasing, shadows, and texture default values. Delete the settings file and test. Test to see if the quality level is changing correctly. Be sure all the quality settings are correct. Ensure it is saving correctly. Does it change to custom if you choose an individual setting? Now, it can be kind of unintuitive for the user to be able to choose custom under the preset, since we do not actually save their preset values and reassign them with whatever dropdown we currently have. So, either make the reverse interaction so users can save their custom settings and compare them to other presets, or just disable the button. We will just disable the button. We'll make a script called disable dropdown option. Inside the script, delete the update function and surround it with a namespace. Add 3 variables. One will be an array of strings that will be used to determine which options we should disable, one will be a toggle that will affect how we disable the dropdown option, and one will be the item name that takes on the item's name and splits it based on the colon separator. We'll find the toggle on the item, split the toggle name by their colon, trim each item, and determine if the item name matches the one that we specified inside options to be disabled. Once done, access the component again and assign custom as the option you want to disable. Everything should be working fine now. Test all individual settings and see your environment change. Ensure all is correct and working. Also, test this in build. All the settings should first emulate your default settings, then every change you make should be saved and applied properly. With that, we have finished a good portion of our video settings. While I hoped you liked this video, we're almost done with our video settings. In our next video, we'll continue with the rest of the video controls such as pixel light count, anisotropic textures, soft particles, LOD, and particle raycast budget. Thanks for listening, and I'll see you next time.